Okay, unlike Salvatore, because I represent the enterprise side, it will be PowerPoint presentation, sorry. And also I have some family guests, so it not be so technical as Salvatore, but let's see. So the title of this presentation is why Redis needs enterprise. And I think you all aware of this system that practically says that if you want to guarantee 100 millisecond response time end-to-end from the time you click the button until you get the first byte of the response, you need to make sure that your database is able to execute most of your requests, if not all of them, under sub-millisecond latency. And the main reason is that you split the entire latency to 50 milliseconds for the network and 50 milliseconds inside the data center. And in most cases, for every user request, you have multiple requests between your application and the database. So the database, in order for this to be under 50 millisecond latency, your database practically needs to answer in no time. And we all know that there is today only one database on Earth that can do that, and this is Redis. And let me use this stage to tell you a very interesting story. About a month ago, I was part of an escalation process in one of the Israeli companies that lives in the tower of Sarona, I think, yeah? And this team were accessing us, was accessing us and telling us, listen, the entire team stayed at night because Redis fucked it up. And when we analyzed the problem, we found that due to some latency, Redis, instead of performing with 0.25 millisecond latency, all of a sudden it was performing with 0.5 millisecond. And this caused the entire application to be slow, and the user will suffer, et cetera, et cetera. And this is just one example of many, many examples why you must have a sub-millisecond database in order to be able to confirm with today's way that the applications are deployed. Now, this belongs a bit to the past. It is well known already. And today, I would like to go with you on the journeys that our customers are doing these days, in which they move their data from traditionally around few gigabytes of data set in Redis to terabytes data sets and even petabyte data set inside Redis. And the first questions that people are asking us is whether Redis can actually be a real database. Whether can you Redis Labs or with your Redis Enterprise can guarantee at least 4 nines of availability. And the answer is a bit complex, and it's split into a few stages. So first of all, let me share with you our history, the Redis Enterprise history. I like this slide because I show it almost every Redis day, and I just changed the red numbers. So we are practically 6 years in deployment, around 900,000 databases under management, running over 3 clouds and 50 data centers. And during this time, we suffer from something like 3,000 node failure events and over 100 complete data center outages. And for those users who enable all the HA features of the product, it is unnotable if we lost any data, yeah? So instead of showing this slide over and over again, we try to share some of the success with the users. And about a month ago, we published this SLA policy for our Redis Cloud users. So if you use a standard deployment, that means a single data center with HA, of course, we guarantee 3 nines. But if you move to multi-AZ deployment, we guarantee 4 nines. But if you insist on active-active deployments, that means across data center, multiple regions, we allow you to work with 5 nines uptime. That means every month, if your application cannot access Redis for more than 26.3 seconds, we will pay you money. And there is only one more database that guarantees that. This is DynamoDB of AWS, and we will talk about DynamoDB later. So if you want to look what runs behind the scene, and this is, this is the traditional main features of every database system on Earth. You need to have true scaling, you need to have HA and failover, you need to have data persistence, you need to have backup and restore policy, security, active, and a well-defined model of consistency. Now, I cannot go over this list because it's a bit too far. Let's focus about just a few things. First of all, persistency, because I guess some of you don't think that Redis can be persistent. The first thing I would like to talk about persistency is the differences between persistency and durability. Now, this slide shows you two different configurations. On the left side, this is a persist but not durable configuration in which you have SSD inside. SSD is used as the storage for Redis inside your instance. On the right side, you see a persist and durable configuration where your storage is outside the instance. Now, why this is a persist configuration? If you restart Redis, it will read everything from the storage. But if a node failure event will happen, in the left side, you will be allocated by your cloud provider or by your Kubernetes system another instance or pod. And this instance will be empty because it cannot use the persistent storage of your previous instance. On the other end, if you use a durable configuration, this instance can load the data from the external storage and you are set. Now, why this is extremely important for the Redis case? Because if you compare in-memory database like Redis with disk-based database like all these other, and usually in the cloud environment, there is half a millisecond latency between your database and the storage. If you do a write command, Redis only have to do a single IOPS most of the time. It really depends on the size of the object, but usually it's a single IOPS. On the other end, disk-based database need to retrieve the data, traverse over the B tree, so that means multiple traversal between the database and the storage, and it's about 50 milliseconds, if no more. Yeah, this is like 100 times faster. And if you do a read operation, this is even faster because Redis doesn't need to do anything. It just serves everything from the memory. And this is 500 times faster than traditional database. Now, this slide is very interesting. You can ask yourself, why do you need durability? Because you have replication. And the funny thing is that when you usually talk with people about Redis, they said Redis is not persistent. Then we show them the previous slides, and then they say, okay, Redis is persistent, but if you have replication, why do you need durability? So this is fine. You can work with Redis without durability. It works faster than anything else. But you need durability in cases where the majority of your instances in the cluster fail. Yeah? And then you have a few options, or to take your backup from a few days ago, or to take your backup from 1 second ago, or to take your backup from the last write. And this is why you must have durability if you want to maintain zero data loss. And just to go very briefly about the advantage that we provide with Redis Enterprise, so we allow you to practically run many Redis instances over the same cloud instance, accessing the same storage without contention in a very fast manner. And in addition to that, we allow you to do that while you do AOF rewrite or backup, which applies a lot of load over the disk system. And last but not least, if there is a failure and you need to take everything from the disk, we can guarantee the SLA, the amount of time it will take you to recover. And this is a very fast storage engine. If you use strong enough storage behind your instances, you can reach to something like 500,000 ops per second for a single instance if you write everything to the disk with every Redis command. This is like why persistent is important. The next thing I would like to mention is the active capabilities that we lately added to Redis. Now, you don't need to have terabyte of data or petabyte of data in order to enjoy the active-active. You can use the simple session management capability of Redis and enjoy the active-active. And why do you need so? Because if you deploy your application across multiple data centers and your DNS throughout your user between data center, you don't want them to lose all the cards on everything that they put inside their session, yeah? This is very, very important, and today, practically 60% of our large enterprise deals is with active-active capability, and this is one of the reasons. But you can also be smarter and develop your application in a way that it's concurrently active, read and write from multiple data centers. And this is the other configuration. Now, you know, active-active is not new, yeah? Cassandra used to have, and then Dynamo, active-active, something like 10 years ago. But what's the problem with Cassandra-like topology is that for every read or write, you need to wait for the majority of the replica to get your request. And that implies 100 millisecond latency. You remember, we talked about 1 millisecond, and you now deploy in active-active manner, it's all of a sudden 100 milliseconds. And if you use Spanner, which is a fully consistent database made by Google, you probably need to wait 200 milliseconds. So this is one of the problems with active-active configuration today. The other problem is related to conflict resolution. How actually you do the conflict resolution when multiple writes appear in multiple data centers? Do you do it at the application level? I don't know about many users who can develop such a logic. It's extremely complex. Or do you use last write win, the traditional ways of database to do conflict resolution? If you do that, in many of the complex Redis data structure, you just lose the data. So it is not good enough. So about 10 years ago, a group of professors from Europe tried to solve the problem of, by the way, Google Sheets that was sacked by then, with a technology called CRDT. CRDT stands for conflict-free replicated data types. And what we did with Redis Enterprise, we practically took CRDT and applied it to Redis. And by the way, we took the lead researchers of this group and hired him to Redis Labs as well. And eventually, what you have with CRDT, and I won't get into the details, but practically, the way it works, from the developer or from the application perspective, you got a millisecond latency when you read and write from the database. And behind the scene, everything is converged without a consensus protocol between the replica. This is a kind of magic, but believe me, it works. In addition to that, CRDT provides a very fine-grained conflict resolution mechanism per data types of Redis. So here and there are still last write wins, but there are more complex conflict resolution like observe removes and hard wins, et cetera, and again, I won't get into that, but again, it works in a transparent way with the existing Redis API. So just to sum it up, if you use active-active configuration, you have practically 3 options. You can use the Cassandra or the Dynamo options, which will result with 100 millisecond latency and what is called eventual consistency. Alternatively, you can use Spanner from Google with 200 millisecond latency with strong consistency, or you can use the Redis CRDT base, which is strong eventual consistency. This is not a marketing term. This is a real academic term, because you have eventual consistency without consensus protocol. And in addition to that, we added causal consistency, which allow you practically to make sure that each replica get the order of event like any other replica. So all in all, it feels like a strong consistency, and everything is done by sub-millisecond latency. So this covers the first paragraph, I think. You can believe me that with all these capabilities and the 5 more subjects, Redis can be treated as a primary database. Now, the question should be asked, Redis is expensive. You are using RAM. RAM is extremely more expensive than Flash, and this is correct. So today, if you look at Amazon, for instance, on AWS, you can see that large instances have something like 768 gigabytes of memory, and it is very, very fast, but it's costly. But you can choose to use with another configuration, just pay 15% more, and you can add a large amount of SSD, and you can use our Redis on Flash technology and store 5 times more the data. Redis on Flash treats the SSD like a memory extender, yeah? The only problem with Redis on Flash is that it's slower than RAM. It's about 10 times slower than RAM. This is still 100K ops per second, which is a lot for a single instance, but there are some users who are thinking that this is not fast enough. So someone needs to bridge this gap, and luckily, Intel has been developed this technology that is called persistent memory. Everyone heard about it? 3D crosspoint. What is 3D crosspoint? So it's about time to hear about it, because in a month from now, it is going to be available at least in one of the clouds. And you know, cloud allows you to introduce new hardware in a very fast manner, yeah? Just 2 years ago, no one here knew what is NVMe, and today, everything in the cloud is NVMe based. So persistent memory will probably be the same. Persistent memory is to take the flash technology that is behind the scene of the SSD and to put it in the memory DIMM. So you enjoy the speed of the bus, but the cost of the SSD. Okay? With persistent memory, a single server like this is able to do around 1 million. It's less than RAM, but very close to RAM, and it's much cheaper than RAM. It's still more expensive than flash, but it's like a kind of a mid-ground. So to help you, we did this complex configuration. You don't need to understand this, but in general, the y-axis shows you the size of your data set. The x-axis shows you the throughput that you need. If you have a very little data set and you need the speed, of course, use just RAM. But if you have over 50 gig and less than 100K ops per second per node, you can use the NVMe, which is good. But if you have beyond 100K per node, just use persistent memory. And why is this important? Because if you want to deploy a multi-terabyte data set cluster on, for instance, AWS, let's take this example, 2 terabyte in total in about 100K ops per second. And let's look at the alternatives that you have today in the market. So first, you can use a service called Elasticache. I guess most of you know what it is. It's a Redis service of AWS. Yes, AWS has this habit to take an open source code that they didn't deploy, package it as a commercial product, and sell it without contributing back to the community. But let's leave it for another discussion. And this is called Elasticache. We are fine. This is fine. This is cost something like $725K a year. This is our high prices. You can do it yourself and work with the open source Redis, which is about $500,000. Or you can go to DynamoDB and pay just $400,000 a year, but pay for this 10 millisecond latency, because DynamoDB cannot go below 1 millisecond latency. Or you can use Redis on Flash, and it will cost you just $145K a year, and sub-millisecond latency, and up to 80% saving. So I think I answer your concern or typical concern regarding whether Redis is expensive or not. And the third and the last request we usually have, can we do more than in Redis? Can we add more use cases? Can we add more data type, et cetera, et cetera? And let me review a few things that we did last year at the Redis Conf in San Francisco. So we developed an application that takes the Twitter stream, does a word count, indexing search, and social graph out of it. And we try to develop it over the AWS infrastructure. So you take the stream, you put it in Kinesis, which is the stream engine of AWS, and then you need to develop a Lambda function that takes the data from Kinesis and put it in Elasticache in order to count the word. But Elasticache is not a database. It's a caching solution. So you need to develop another Lambda functions, take the data from Elasticache and put it in DynamoDB. And then you need to develop another Lambda function to take the data from Kinesis and search it. But the cloud search of AWS is slow. You need to cache it. So you need to develop another Lambda functions that take the data from the cloud cache to Elasticache and cache it. Now you need to build the social graph. So you need to develop another Lambda functions that takes the data from Kinesis, put it in Neptune, and serve it. But Neptune is also slow. So you need to develop another Lambda function that takes the data from Neptune, put it in Elasticache, and cache it. And then you just need to connect your application to this mess, and this is wonderful. It looks like this. This is the spaghetti architecture of AWS. It is complex, it is expensive. You like it because you develop a Lambda function, but eventually this is what runs behind the scene. You have 5 data services, 6 Lambda functions, 5 application connectors, and 7 networks up. And it is fucking slow. Yeah? The database itself is 100 millisecond latency, and from the user perspective, it is seconds. Your user won't like it, for sure. There is another alternative. Do everything in Redis. You have built-in data structure for stream, you have built-in data structure for sorted set, and you load 2 wonderful modules that we will discuss today, one of them called Redis Search, and one of them called Redis Graph. And you just need one data device, one data service device, one application connector, and one network hop. Now the questions that need to be asked, can this be done in less than 1 millisecond latency? This is a difficult question, and it has 2 parts. The answer has 2 parts. First of all, everything we do with Redis Enterprise, we want it to be at least 10 times faster than anything else. Otherwise, we don't do it. So Redis in RAM, as I mentioned earlier, is 500 times faster than any other database. Yeah? Redis on Flash is just 50 times faster than any other database. If you use our active technology, it is 100 times faster than Cassandra or Spanner. If you use Redis Search, we have a session about it. You will see how much it's faster than Elastic. Redis Graph, we have another session on it today, but I'm ready to expose that this is 2,000 times faster than the other graph database. And if you use a simple Bloom filter mechanism, you can have 70 times faster in Redis. This is the first part of the solution. Probably the most challenging part is how you serve everything under sub-millisecond when everything works together. Unfortunately, this event is 1 month before the RedisConf, which is going to be next month, and we are going to announce how we do it then. So I cannot expose the detail. I'm just going to tell you that we are going to show you how to do it. You should watch the video. Just come to RedisConf. If you arrive to San Francisco, this will cost you less than a Uber drive, only $49. Yeah? We like the community, so it is not expensive. And everything will be shown there. Last but not least, Redis is no more simple. It's based on a very simple and robust architecture, but you can do many, many things with it. So we developed this wonderful tool called Redis University. It's a browser-based IDE. You don't need to do anything. And we try to teach you how to use the state-of-the-art capabilities of Redis. Not only the state-of-the-art, there is basic data structure course, Java courses, but there is also Redis Stream and Redis Search courses and more courses to become in the next months. Thank you very much.